Ever tried learning something new, like driving a car or mastering a video game, by only reading a manual? You might grasp the basics, but real-world practice is what truly hones your skills. That's the same challenge AI faces when learning to make decisions. Today, we're diving into a breakthrough called online pre-training, OPT, a technique that helps AI systems bridge the gap between learning from historical data and adapting to the real world. Let's unpack how it works. Reinforcement learning is like teaching a robot to walk. The robot experiments with movements, receives feedback like a reward for staying balanced, and iteratively improves. But here's the problem. Training AI purely from pre-recorded data, offline learning, is safe but limited. It's like studying a textbook without ever taking a test. On the flip side, online learning, where the AI practices in real time, is powerful but risky and resource-intensive. The core issue: when AI transitions from offline data to real-world environments, it often fails catastrophically. Why? Because the real world rarely matches the data it was trained on. Think of it like a student who memorizes old exam answers, but panics when faced with new questions. This mismatch, called distribution shift, is a major roadblock in AI development. Enter online pre-training, OPT. Imagine it as a bridge course for AI. Instead of jumping straight from offline data to real-world practice, OPT adds a third phase, online pre-training. Here's the breakdown. 1. Offline pre-training. The AI studies a vast data set of past experiences, like a student cramming for a test. 2. Online pre-training. The AI begins interacting with the real world, but with safeguards. It uses balanced replay, a technique that mixes old data with new experiences to avoid distribution shift. 3. Online fine-tuning. Finally, the AI refines its skills in real time, now better equipped to adapt. The secret sauce: a parameter called kappa. Think of it as a dial that balances how much the AI trusts its old knowledge versus new experiences. Early on, it leans on offline data, like a student relying on notes. But as it gathers real-world feedback, it shifts to new data, like a student trusting their practice. This gradual transition keeps the AI stable and effective. In tests across challenging environments like MuJoCo, robotics, Antmaze navigation, and adroit hand robotics, OPT boosted performance by 30% compared to older methods. Even with messy or incomplete data, it outperformed competitors. And here's the kicker: it's flexible. Researchers tested OPT in robotic simulations, comparing it to traditional methods. They measured how well AI adapted across trials, essentially, how consistently it could learn. The results: OPT outperformed older techniques, but the real twist was its focus on live interactions. Even when simplified to online replay, a method prioritizing real-time feedback, the AI still improved. This suggests OPT's true power lies in its emphasis on real-world learning, not just static data. Take a look at these numbers. In some tests, OPT boosted performance by up to 30%. But it's not just about the numbers. The study explored a parameter called kappa, which controls how much the AI relies on old data versus new feedback. Surprisingly, the exact setting of kappa didn't matter as much as how it changed over time. A slow, gradual shift, like a gentle nudge, worked best. It's like teaching a child to ride a bike. You don't yank the training wheels off all at once. They also tested what happens when you remove parts of the system. One experiment stripped away meta-adaptation, the AI's ability to adjust its own learning strategy. Without it, performance dropped, especially in tough scenarios. But when they kept that feature, the AI stayed stable and kept improving. It's like giving the model a built-in compass to navigate uncertain terrain. Now here's where things get really interesting. When researchers pitted OPT against other cutting-edge methods, it consistently came out on top. Unlike some approaches that rely on complex, resource-heavy techniques, OPT achieves better results with simpler, more efficient training. Think of it as a high-performance engine that doesn't burn through fuel. Why does this matter? Imagine self-driving cars that adapt faster to unexpected road conditions, or medical AI that learns from new patient data without forgetting what it already knows. OPT isn't just a technical tweak. It's a step towards smarter, more reliable AI that can handle the messy, ever-changing real world. So what's the takeaway? Small changes in how AI learns can lead to big leaps in capability. And as researchers keep refining these methods, we're one step closer to machines that don't just mimic human intelligence, they evolve with it. Thanks for watching, and stay curious.